Welcome to another episode of Numbers in Medicine. Today we will be discussing the fundamentals of biostatistics. The objectives for this lecture include: learn to develop a 2x2 table comparing the test results to the disease state, define and calculate sensitivity, specificity, positive predictive value, and negative predictive value, and finally work through a couple of examples. So this is the famous 2x2 table you'll see in all of biostatistics. It compares the results of the test to the true disease state. There are only 4 possible outcomes. One can test positive for the disease and truly have it. That's a true positive. One can test positive but not actually have the disease. So that would be a false positive. Next, for those who test positive but do not actually have the disease, those are our false positives. Those who test negative but actually have the disease are our false negatives. And finally, those who test negative and indeed do not have the disease, those are our true negatives. Now there are 4 main terms in biostatistics, and we'll relate these to the aforementioned table. They're sensitivity, specificity, positive predictive value, and negative predictive value. Let's take a look at each of these in more depth. The first term we will discuss is sensitivity. It's also known as the true positive rate. It is the proportion of all people with the disease who actually test positive. Mathematically, sensitivity equals true positive over total with disease. But remember, the total with disease is made up of 2 components: those who tested positive and actually have the disease, and those who tested negative, but they actually do have the disease. So true positives plus false negative. You'll hear that sensitivity is important for quote-unquote ruling out a disease. That's because if you have a high sensitivity, that means you have a low false negative rate, which means it's great to screen for diseases. Remember that sensitivity is also inherent to the test. So if I take this same test with the same cutoffs and use it on a different population, the sensitivity will remain the same. It's inherent to the test, not the population of people. So let's look at it here at our 2x2 table. We have our true positives and our false negatives. So it's this first column. And sensitivity equals true positives over true positive plus false negatives. The next term is specificity. This is known as the true negative rate. It's the proportion of people without the disease who test negative. Mathematically, specificity equals true negative divided by the total number without disease. But remember, the total number without disease are those who tested negative and in fact do not have it, but also those who tested positive but don't have it. So it's the true negatives plus false positives are the total without disease. You'll hear specificity is great for ruling in a disease. That's because it has a low false positive rate. So a highly specific test is used to confirm a test after a positive screen. Just like sensitivity, specificity is inherent to the test. So if you take the same test with it to a different group of people, you should get the same specificity because it has nothing to do with the population, but rather the test itself. So if we look here, this is our true negative. And up here in the second column are false positives. Specificity is equal to true negatives over true negatives plus false positive. The third term is positive predictive value. This is the probability that a person who tests positive for the disease actually has it. So mathematically, the PPV is equal to true positives over total that tested positive. But those who tested positive can either be a true positive or a false positive, means they tested positive but they don't actually have it. Now PPV is different from your sensitivity and specificity in that it's not inherent to the test, but it does depend on your sample. The higher the pre-test probability, the higher your PPV. Now all of this will go into more detail when you get an example. It should be a little clearer then. But looking back at our 2 by 2 table, our PPV is equal to our true positives divided by true positive plus false positive. So it's that first row. Finally, the negative predictive value is the probability a person who tested negative for the disease does not actually have it. Mathematically, it's equal to true negative over the total that tested negative. Remember, the total that tested negative is in fact the true negative, but also those who tested negative but actually have it. So it's true negative over the quantity true negative plus false negative. Again, like positive predictive value, it's not inherent to the test. And the higher your pretest probability, the lower your negative predictive value is. So we go back to our 2 by 2 table, we look at that second row, and it's true negatives over true negative plus false negatives. And here are all 4 major values shown that we've already discussed. But one more I want to discuss is the prevalence. Prevalence here mathematically is true positive plus false negative over everyone in the sample. True positive plus true negative plus false positive plus false negative. Said another way, the prevalence is the proportion of people in your sample that have the disease, right? Those who have the disease are true positive plus false negative, and then the other 4 terms together just make up the entire sample. Let's do 2 examples. Example 1, you go to NIM County and they have 1,000 residents. We've developed a test for these residents and we test all 1,000 of them. 180 tested positive, but from our gold standard, we know that only 80 actually have the disease. And conversely, of the 820 who tested negative, 800 do not have the disease. With just this information, we can calculate the sensitivity, specificity, positive predictive value, negative predictive value, and the prevalence. Let's do this step by step. So, first thing we know is we have 1,000 residents. So we go to our 2 by 2 table, and we know the total number will be 1,000. Next, of the 180 who tested positive, 80 actually have the disease. So we know that 180 have tested positive. We go to the row that says positive test, and that total is 180. But of those, we know that only 80 actually have the disease. That's a true positive. Just a little bit of math. I can then say that the false positive number is 100, or 180 minus 80. The next step is, of the 820 who tested negative, 800 do not have the disease. So 820 tested negative. The true negative number is 800. And again, little subtraction. That means the number of false negatives is 20. Finally, we can add up the other columns. We know that true positive plus false negative makes up that bottom column number. So the number who have the disease is 100. And then the number who do not have the disease is 900. Note how all the columns add up to the bottom row. So 80 plus 20 is 100, 100 plus 800 is 900, 180 plus 820 is 1,000. The 1,000 residents we have in NIM County. Now let's calculate the sensitivity, specificity, PPV, NPV, and prevalence. If you want to pause the video here so you can calculate the sensitivity, specificity, PPV, and NPV on your own, and then compare, great. If not, we'll start with sensitivity. Sensitivity is equal to true positive over true positive plus false negative. Here it's 80 over 80 plus 20, which equals 0.8. This means of all of those who have the disease, 80% will test positive with our new test. Next is specificity. It equals true negative over true negative plus false positive, which equals here 800 over 800 plus 100, which equals 0.89. This means for all of the people who do not have the disease, 89% will test negative with our new test. Next is PPV. It's equal to true positive over true positive plus false positive, or 80 over 80 plus 100, which equals 0.44. This says for all of the people who tested positive, 44% will actually have the disease. And finally, NPV, which is true negative over true negative plus false negative, which equals 800 over 800 plus 20, which equals 0.98. This says for everyone who tested negative, 98% of them will not have the disease. And using these terms, we can easily calculate the prevalence, which is essentially number who have the disease over that total population. It's 100 over 1,000, which is 0.1. So 10% of this sample has the disease. Example 2. Very similar, but instead of NIM County, we have ABC County. They also have 1,000 residents, 490 tested positive, but only 440 of those actually have the disease. And of the 510 who tested negative, 400 do not have the disease. Calculate again the sensitivity, specificity, PPV, NPV, and prevalence. So we know that ABC County has 1,000 residents. Here we were able to sample the entire population, so our sample size is 1,000. So in that bottom right-hand corner, total number is 1,000. Next, of the 490 who tested positive, 440 actually have the disease. So 490 tested positive. True positive is 440, and with some subtraction, false positive equals 50. Second aliquot of information, of the 510 who tested negative, 400 do not have the disease. So 510 tested negative. True negative equals 400. And again with subtraction, false negative is 110. We can go ahead and finish out that bottom row. Total number with disease is equal to true positive plus false negative, which equals 550. Total number without disease equals false positive plus true negative, which equals 450. So let's calculate the sensitivity, specificity, PPV, NPV, and prevalence. Again, feel free to pause the video if you want to work on these numbers by yourself to compare. The sensitivity is equal to true positive over true positive plus false negative, which is 440 over 440 plus 110, which equals 0.8. This says that for anyone who has the disease, 80% of them will test positive with our new test. Specificity is true negative over true negative plus false positive, which is 400 over 400 plus 50, which equals 0.89. This says for anyone who does not have the disease, 89% of those will test negative with this new test. PPV equals true positive over true positive plus false positive, which is 440 over 440 plus 50, which equals 0.9. This says for anyone who tested positive, 90% of those will actually have the disease. Next is NPV, or true negative divided by true negative plus false negative, which equals 400 over 400 plus 110, which equals 0.98. This says for anyone who tested negative, 98% of those will not have the disease. And finally, our prevalence is equal to total who have the disease divided by the total number, which is 550 over 1,000, which equals 0.55. So 55% of the residents in ABC County have this disease. The final thing I want to do is compare the values for NIM County and ABC County. Even though these are two different populations with different number of people with the disease, the sensitivity and specificity are the same. This is just a friendly reminder that sensitivity and specificity are inherent to the test. They're fixed properties. So going from one population to another won't change the sensitivity or specificity. However, note that the PPV and NPV are different. It increased from 0.44 to 0.9, the PPV did, from going from NIM to ABC County, but decreased from 0.98 to 0.78 when going between the two. This is because the prevalence of the disease is different. We said that when your pretest probability is higher, in this case, when the prevalence of the disease in the population is higher, your PPV increases and your NPV decreases. And you can say the opposite. When your pretest probability is lower, your PPV is lower and your NPV is higher. And we see this just based on these two examples. This was a brief introduction to the fundamentals of biostatistics. Thank you.